is actually kind of part of an internal presentation I gave at Konrad almost a year and a half ago now. And so Luis has updated it and has some more stuff, but Luis can answer questions in the chat. But one of the things I want to talk about is like, what is a SerDes camera? So interestingly enough, before we were Konrad, we were VI engineering, and we actually did a lot with cameras back then. We actually have a dark room or a camera room, but a lot of it back then was with biomedical and sciences and telescopes and your gigi cameras. So I always found it super interesting that Konrad kind of went from, or VI did that type of cameras, and now we're kind of moving into this type of cameras. It's just a different type. It's all the same. But what is a camera in general, I guess? So every camera is a sensor. So how many of you have a, what's it called? Like a digital SLR camera? Have you guys ever looked at that or seen how it worked with like the mirror? You take the lens off, you can kind of see when you click it, how the mirror moves. It's like a sensor in there. And so every camera itself has a sensor. So there's different sensor manufacturers. But then beyond that, there's a protocol. And like on my cell phone, I mean, nowadays, everyone's cell phone takes crazy cameras and photos. And like mine has 3 lenses and different things, 3 different sensors, right? And the crazy part is there's this whole standard out there called MIPI. And that's the mobile industry. I don't remember what the whole thing stands for. I have more information on it later. But there's a standard, and it's a camera serialized interface. The problem with that, though, is it's a very short trace. It can't be a long cable. And so in order for these cameras to be used in like robotics type applications, which are some of the projects I'm currently working on, or in automobiles, you need to take it to a different physical layer. And so they put a serializer, shown here is like the SIR, on the camera. Some of these cameras do a little bit more beyond that. And Mobileye is the biggest manufacturer of this type of camera, I'll say. But they basically put an ISP or a processor in line. So direct from the sensor, they're putting it into a chip, and they're taking data or doing something with the data before they serialize it. So it's a little bit different. But these are the 2 main types of SerDes cameras. The key part being you're taking data, whether it's been processed or not, and serializing it. So you can take it out a different physical layer and run it through really long cables, for instance. So an image sensor in general, this is for every camera. There are 2 main types. There's a CCD or a CMOS. The CMOS is the most common because they have higher frame rates and resolution and lower power consumption. The CCD are more of the original cameras you'd see in the early 2000s. But all an image sensor does is convert light to an electrical signal. And different cameras convert things differently. We have a camera and a customer we're working with right now, where not only are we getting what I would call a picture, which is what we normally see as a human or expect from a camera, but we're also getting depth data from the camera, which is an array showing distance information from the object it's photographed, as well as IR data. So from one camera, we are getting 3 different image streams: an actual picture, IR data, and the depth data, which is kind of cool in my mind. So it's basically what's a camera? It's a sensor. And ISP is the image signal processor, and these are typically system on a chip on there, and they can do a bunch of stuff. So it can correct for stuff on there. It can do noise reduction. It can do color filtering if you want it to. There's all these different things that happen with the camera. I do robotics as well, and one of the biggest things in any camera application with like the kids I'm working with for middle school and high school, or even in my job, is lighting. Lighting makes the biggest difference. So depending on how your light is, you could have a good image or a bad image, right? And so there's different things you can do to the exposure of your camera sensor to affect, that affects how the lighting works. And so there's all these different things, and some customers want to do it in line, and others will do it later. They're like, just give me the raw image data and I will deal with anything else later. Where do you see these cameras in general? So the largest in-vehicle camera operation I've seen was for an OEM right now, and they had 11 cameras on the vehicle. So this is not a vehicle that you'll see today, that I could go buy, but this is something in the future that they hope to have. And so they had multiple side cameras so that they could have a 360 view around the vehicle. They had cameras in the front, cameras in the back, and a lot of times the cameras in the back, like my husband actually just bought a new pickup truck, and it's got a huge trailering package, and it's insane to me, but like there is a special camera tilt that he can view in his display in the vehicle, so that as he's backing up to hook up his trailer, you can immediately see where he's at and where it's aligned. It's this camera that's angled down. So there are literally 3 separate cameras in the back of his new pickup truck that are there. But the one we're working with has 11. It's got like the 3 in the back, it's got 2 on each side, and it's got 2 in the front, and it also has internal cameras. This is something more and more with the autonomous, as they're trying to move to full autonomous, is driver awareness cameras. So yeah, you can have full autonomous, but if there's a driver there, they shouldn't be sleeping. They should be ready to take over the wheel if something happens, right? And so these are more cameras you'll have. Now, no 2 cameras are equal. This is the really interesting part. On that system that we worked on that had 11 cameras, 5 were of one type. Those were basically our surround view cameras, the ones on the side and in the front. The cameras in vehicle were much lower resolution and slower frame rate. And then as well as the trailering cameras were a little bit lower resolution and frame rate. So in the end, they had 5 different camera sensors and 11 different cameras. So 11 cameras, but only 5 different camera sensor types. So you got to kind of watch as well, because different resolutions, different frame rates, depending on the application, it can all change. General use of how you see these. So you have all these different cameras on the end, and they can be serialized. Now this is showing also HDMI data. So what that means is we can serialize data from other things. So these same chipsets that I'm going to be talking about from 2 main manufacturers can serialize not just from an image processor, but it can serialize camera data. So you can kind of see different things. We could serialize, for instance, data from a simulation environment, right? Every serializer needs to have a deserializer pair. That's how it works. It serializes it, then you need to have the matching deserializer, which would then go to your ECM or your electronics control module, which might have an image processor in it or not. And it may serialize it out and pass it on to a display or something else, right? Depending on in vehicle. And one thing to watch out for is one manufacturer of serializer deserializers has a very similar chipset for displays, but the NI hardware I'm going to talk about does not support that. So a lot of the display deserializers are not supported directly by the NI equipment. So that's just a little bit of a gotcha. So how is the image serialized, deserialized? Basically, it's taking your horizontal lines, and you've got sync lines, you've got the bytes that are the actual images, you've got frame syncs, you've got all these different things, and it's putting them into different lanes. So instead of having one big long stream, it breaks them up so that more things can be sent in parallel across the board. So there's a lot of different configurations for these serializer, deserializer chipsets, because you have different lanes that you can configure, as well as the number of information you pack into each lane and the data rate per lane. And then here's kind of an example of video. So Luis has, I think this is a video that's 24-bit pixel frames per second. And I think, is that the number of bits or pixels that's being transmitted, Luis? He can maybe comment in the chat there. This is one of his new slides. Bits, it's the number of bits going. Okay, so you'll see here, it's got the source data, and you've got a bunch of different clock lines. You've got your actual color data information coming through. It's serialized, and at that point, you're passing through the pixels, and then it goes down. So this is just kind of a zoomed in of the last one. Other features in SerDes cameras, I2C. So there's an I2C bus that is in transfer with the serialized information. And what that allows you to do is program the camera or other devices that are on the I2C channels. So you have to know the addresses. This is a little bit of a gotcha when we start looking at NI equipment, is every camera sensor itself will have an I2C address, as will the serializer. So if we put ourselves in the middle to be in tap mode so that we can kind of listen in, we have to make sure to pick different. We want to kind of copy the setup, but we have to be different addresses, or else we're causing bus conflicts for I2C. But there was an instance of a customer where they wanted to change their exposure on their camera, and that was actually an I2C setting. So one of the things we would do is we would read in an image, we would pass an image to a DLL that they provided us because they didn't want to give us all their IP. But from this DLL, it would give us an updated value that we needed to tell their camera over I2C to set the exposure control to. So we kind of had, as we were driving along recording data in the loop, we were able to change the behavior of their camera based on the images that were coming in. This was something that they wanted their ECU to be able to do, but they also wanted to test some of their algorithms as we were running in vehicle. The other thing you can do with the SerDes is GPIOs. There are a bank, and I think there's actually more of them with one of the types than the other, but there's a bank of GPIO lines that you can use. They're just multifunction. You get to determine as a user if they're inputs or outputs and what you can use them for. A lot of times they're used for synchronization with other sensors. They can also be used to trigger frames from a camera. So for an agricultural customer, they were designing a tractor that as it went through the fields, there was cameras on each of these spray nozzles, and it was a stereo camera. And as it went down, it would basically look at the field and it would be like, is that a weed? And if it was a weed, it would kill it. And if it was a plant, it would fertilize it. And so the stereo camera, though, because of how they wanted to angle their cameras, they had two cameras and they wanted two images taken at the exact same instant in time. So the camera sensor that they were using had a setting that it would send an image on a high pulse. So we were able to, with the customer, use the GPIOs, and that every time we sent a pulse on a GPIO line, and because we were using the NI-FPGA, we could do it truly in parallel, we would send a pulse over that, and it would give us a pair of images back, and they were taken at the exact same instant because we had the hardware synchronization there. So that's one instance when you could use GPIOs with these. So NI kind of has this setup, and they'll talk to you about different types of camera applications. For the most part, you have your product application, which is no NI equipment at all. You have some sort of ECU or ISP or something that's, some sort of computer, if you will, and you have the camera. So you're commanding it over I2C, maybe you're using GPIOs, and you're getting data back. So that's the end user application typically. The NI has a card they released. I think the first one probably released a couple years ago now. There was a 1486 and a 1487. And I'm going to go into detail on these two cards in a little bit. They are very expensive cards. I think right now they sell for $17,000 for one card. It is only in PXI right now, but these are SerDes cards. So they are meant to be paired with either the ECU, the camera, or both. And you could use this card, for instance, in loopback mode. So customers could pretend they're the camera, they could pretend they're the ECU and do whatever they wanted with it. More common applications, though, would be acquisition, so logging. So not even have an ECU, I'm just using a camera sensor and I need to log it. Or tap is probably the most common one I've seen, where we sit in the middle. So we are kind of the middleman, we're sitting quietly there, we're allowing the ECU, we're passing through the I2C commands from the ECU over to the camera, and then we're tapping the data. So we're forwarding the video data on, but we are also recording it internally as well as the I2C traffic. So we can see what commands happened and what video happens. We can kind of post-process and see the full communication there. The other type is pure generation. So a project Luis has been working on for a while now involves us. It's for a consumer electronics customer, or I guess just consumer, but they have a robotic for their warehouse, a robot, and they have 5 cameras on there, 5 SerDes cameras for autonomous movement in the warehouse. And what he's doing is, Luis right now, is every time they give us a new firmware reversion, we need to go record data in tap mode, and then we need to be able to, in their safety lab, play it back. So we're just doing pure generation, basically, but we're also adding faulting so that they can test their software as they go along. And so another thing you'll see more and more, and NI likes to talk about, is hardware in the loop. So I always say there's kind of two things there. Hardware in the loop is more, we're taking log data, we're playing it back, maybe we're closing the loop there so that based on information, we can change values or fault values. Software in the loop is very similar, except we have simulated data being fed in. And then we have hardware in the loop with I2C and software in the loop with I2C emulation. So the difference here is we need to have a camera up top because we are not responding to the I2C commands. The camera would actually be responding and making changes based on that. With the below, we can take the camera completely out. This requires a full knowledge of the camera and the ECU, though, and the handshaking. So if a customer doesn't know this, this is very difficult to us to do because we're not the camera manufacturer, we're not that person, but we do have standard things we can emulate and reply back, right? So the idea here is you have a lookup table, and if the ECU says, hey, do this, we need to be able to reply, and maybe it was change the resolution. So then from our simulated environment, we need to change the resolution of the image we're passing through. Any questions on all the different types of camera applications? And Bill, I'm going to go into the two chipsets a little bit later too.
Thank you.
Yep. So behind the scenes, this is where we're going to get into the chipsets a little bit more. There's a lot of protocols and stuff going on. The lowest level layer is this MIPI CSI2 that I'm going to talk about. And this is actually came from your cell phones in the cell phone industry. And then we'll get into what FPD-Link and GMSL is. And those are the two SerDes chipsets. Those are the main ones that are out there. So in general, I've been talking about a lot of these, but I have like this page of acronyms so that everyone can kind of go back to it. But SerDes, when you use that terminology, or a lot of times you hear people say LVDS, but the idea is it's a serializer-deserializer pair. So it's a set of functional blocks to compensate. So LVDS is low voltage signaling, low voltage differential signaling. And that's actually like a physical layer used by the SerDes chipset. So that's why a lot of people call this LVDS. But the true terminology is actually SerDes, because what we're doing is converting it between serial and parallel interfaces. So we're basically taking it, serializing it to spit it out over a wire, and then we have to deserialize it on the other end. Now, this is separate than what happens behind the scenes. Behind the scenes is MIPI CSI2. So MIPI, like I said, came from the cell phone industry. That actually started in the early 2000s when cell phones started having cameras and things. CSI2 is a camera serial interface, and it's the interface between your camera and any host. So we're basically going MIPI CSI2 to SerDes. And the one that's most common and used across the board right now is CSI2 version 3, and that was released a couple years ago. There is a CSI3. It's not even used in cell phones or anything yet, and I don't know if it will be used or not. CSI1 was used for quite a few years. CSI2 is still in use, and CSI3 I feel like is still kind of in the R&D phases. But there is a whole website. Konrad is a member of MIPI, or at some point we were part of it, because I know we actually have the full specifications. You have to join the organization. It's kind of like the PXI Systems Alliance or any of those other IEEE things. It's a standard, it's out there, but you need to be a member to get the specifications to make stuff. We have joined because we do make different products that I'll talk about later on that use CSI2 and different things. So the next thing up is the main protocols and the main SerDes chipsets. And so that's FPD-Link and GMSL. So TI, or Texas Instruments, is the one who makes FPD-Link. And just to confuse everyone, FPD-Link started out as only a display thing. So it actually stands for flat panel display link. So they kind of got rid of that when they started using it more for cameras too. But this is the one you have to really watch out for chipsets. I know my husband's vehicle has a newer display in the front that has like the CarPlay and all that fun stuff. And it's an FPD-Link 4 display. And the cameras in the vehicle are FPD-Link 3 as well, because there's a lot of compatibility between them. And what's interesting in there is, like the NI equipment, we can read the FPD-Link cameras, but we can't generate FPD-Link display because we don't have the appropriate serializer to go to their chipset. So it's a little bit interesting, but I know I've worked with this in the past. NI has kind of thought about it, and I know they're still on the fence. They've had a few customers ask for it. So if you're interested, the way they've designed their architecture, just keep hitting them up for any of these chipsets. They're trying to go with the most common. And if not, Konrad can custom do it. It just takes a long time and takes a lot of money. So that's, I'm not going to lie, that's kind of the thing. We can do custom boards. We've done it in the past. But it's more than if you could get NI to do it for the product, right, and actually have it be out there. So they're still kind of investigating, do they need to make a display version, or are the camera ones good enough? Right now, they're sticking to camera. GMSL is from, it started out as Maxim. Maxim was purchased by Analog Devices. And so now it's ADI technically, but it's GMSL, it's Gigabit Multimedia Serial Link. And you'll hear GMSL2 and GMSL3 are the two common ones. So FPD-Link, you hear 3 and 4 typically, and GMSL 2 and 3. And NI does have support for all 4 of those main chipsets. I2C, that's the communication bus we talked about. Most of you are probably familiar with that. And then GPIO is just general purpose signal that we can deal with. So MIPI CSI2. There's like, here's the website to go there, and they have a lot of good diagrams and things. MIPI CSI2 walks you through the entire physical layer that you can use. So this is the one that is in like your cell phone. So whether you have a Samsung or like an Apple or whatever device you have, I guarantee the chipset inside of there is, it is using CSI2. It is a very, very short cable from a physical layer. So this is why you have to go to the SerDes, because, and I forget what the restrictions are, but it's limited there. So there's 4 wires, it's scalable, but it's very short. And I'm talking like inches, like 4 inches or something is the longest you can run a trace or a wire before you have signal degradation. So there's a whole video. I'm not going to have you guys watch the video, but we'll share the slides afterwards. But this is actually, without the SerDes layer, this is the entire from a receiver to a transmitter layer. So they expect you to have some sort of application that has control lines and pixels. And then you actually have very specific standards on how to pack your pixels into different bytes. And we'll talk about what some of those packing formats are in a minute. That takes us down to the LLP, which is a packet-based protocol. So a lot of the NI driver layer is at the LLP. So when NI is passing around this data, this is what you're dealing with. You're not dealing with the SerDes. You don't need to deal with that. A lot of that's handled by itself, but you kind of get this LLP information, and then you have to pack or unpack the pixels from there. Based on that, NI buried up under the hood has the lane management, and then the physical layer is there as well. And so the LLP, the part we deal with a lot of, is low-level protocol, and it's a packet. And you have short packets and you have long packets. And in the long packet is your actual data. That's where your pixel goes. And so more LLPs built up. You have a frame start, and then you have a packet header. You may or may not have embedded data, because not only can you send camera data, you can send information like, what is my frame ID? What is my resolution? You can bury any type of information. You can bury the serial number of it in there. There's different things you can pack in there depending on how your sensor is configured. And then you have your actual pixel or user defined, so you can even do custom stuff. Then you may or may not have more embedded data. You may or may not have frame blanking. And then you have your checksum, and you may or may not have line blanking at the end. And then you have your frame end. So this is kind of your entire packet as you go along. And this is to look at the raw stream. So LabVIEW and everything else sees this. So what we see here is a bunch of bytes. This is actually an LLP packet capture from an NI card, looking at it in a binary viewer here. It's a hex viewer. And so you can see the first part of the packet is the timestamp. Then we've got kind of the sync pattern coming in. Then we've got the MIPI header. And then we've got some blanking. And then we've got the MIPI payload. So there's different things. We've got short packets, we've got long packets, and then we need to extract out the picture. And so NI has a getting started example that kind of does some of this for you, but it's also important to know that this is really what you're getting under the hood. So you can do more with it than you need to. There may be information buried in here that you need to extract to do something with it. So SerDes chipsets, I also have links to something from TI and another video from Maxim that go into detail on theirs, but I'm going to skip over these because they take a little bit of time. But the basic gist is there's 2 main manufacturers, TI and Maxim/ADI, and there's 2 main technologies, FPD-Link and GMSL, and they're both SerDes. They have a forward interface and a backward interface, they call it. The package size is slightly different. The operating temperature is the same. The bandwidth is different. The GPIOs are different. And then there's a little bit more you can do with FPD-Link that you can't do with GMSL. The main thing being audio. So really what it comes down to is GMSL has a lot more data rate. You have a lot more with the GPIOs, but you can't do any audio at all. It is a bigger form factor to actually use the chipset as well. And I believe, I don't think I have on here, I think it uses more power as well than the FPD-Link chipsets. From a configuration standpoint, Luis can likely talk to this. GMSL is a lot more complexities for the initial configuration of your serializer because there's a lot more options on how to configure it to get to these data rates. FPD-Link tends to be simpler to set up and get running from our experience. Does that make sense? FPD-Link 4 and GMSL 3 are more common. I don't have those on a good comparison chart yet, and these did release earlier this summer. I2C, I'll skip over this. That's just kind of an instruction on how I2C works. Most of you probably know that by now. Same thing with general purpose I/O or multifunction pins. It's part of the SerDes chipset. This is the one thing that is not part of the MIPI CSI2 standard. And again, like I said, it's often used for synchronization. So the packet formatting is kind of the next step up. Is we looked at that very low level bunch of bytes, but the bytes don't mean anything. So we're going to kind of look at what that means. So if we were to take the MIPI CSI2 specification and we had an image that looks like this, let's break it up into pixels. We're going to say this is an 8 by 8 pixel image to be really small. What we're going to do is transmit it like this. We have a start a frame, and then we have 8 long packets that contain the pixel data, each in a row, right? We're going line by line through our image, and the packets would get sent one after another. But that's not really enough because we have to represent the colors somehow. And this goes back to just any type of image manipulation, but colors are typically represented as RGB, where you have like the red, green, blue components, the YUV, where it looks at luma, blue, and red projections, or HSL, the hue, saturation, and lightness of it. And I like this. I found this online at one point, but it kind of breaks up, like to get this top level image, it's adding these 3 lower parts together. So we're looking at the red, green, and blue component, whereas over here, the luma is kind of the lightness, and then we're looking at blue and red projection. So it's just a different way mathematically to look at the pixels so that we can rebuild them into a full image that our human brain likes. And so if we look at what does this pixel look like, just this red one, well, RGB is a little bit easier to represent. You have a red, a green, and a blue component. And then you have like YUV or you have HSL, right? Same thing. And you can do this in like Microsoft Paint or anything, and you can kind of look at the different things. And then there's always like a hex number to represent the color, right? These are all the same, but it's how do I represent an individual color by binary? And so MIPI CSI2 has these different color packing standards. And depending on what color packing standard you have, that tells us how many bits we have to represent each type. So one of them, we have a couple examples I'll go through, but this is RGB 888. And so for each pixel, it takes 3 bytes or 24 bits to represent that one pixel or that one color. So if we look at it here, and I'm looking at just the red, I have individual bits, right? So these are hex, and then I break it down into 8 bits for each individual color. And so you kind of have to do a little bit of math. So how many bits are needed to transmit a 1920 by 1080p image in RGB 888 at 60 frames per second? So you can kind of do some math because it's per pixel. I have this many pixels and I have 24 bits per pixel, and at 60 frames per second, that means I have data transmitting at 2.98 gigabits per second. Okay. So those are things to kind of watch out for to make sure you have enough bits for your representation of your image as well as the data rate to cover it, because there are some limitations. You know, FPD-Link was a little bit slower than I think GMSL could do, like almost up to 6 gigabits per second. But you start getting into some of those 4K images, it gets a little bit crazy. Here's another thing. So this is RGB 565. So it uses 16 bits. So we're using less bits. We're only using 2 bytes per image. So same thing, just represented a little bit differently. And we can kind of go down now we look at YUV 422. So in YUV 422, every Y sample and every other U and V are transmitted. So it gets a little bit weird. So for red, we're going to, if I go back, for red, we're going to transmit the YUV and V value. Then for the next pixel color, we're only going to do Y. Then we're going to do YUV again. So it's a little bit different. And in this case, we're using 32 bits or 4 bytes per pixel. Kind of using the neighboring colors to do that. So it's a little bit strange, but they've got more going. Here's YUV 8-bit. So there's another one to do it again. And I'm going to go through. These are all of the data types that are defined by the MIPI CSI2. So you have everything. I covered some of the RGB ones. I went over some of the YUV ones. They also have raw. So raw means we are passing the full data and not actually pulling color information from it typically. So if you ever looked at a raw image saved on like your camera, like if you have a digital SLR, it kind of has like a greenish purple hue to it, and you have to apply the coloring yourself kind of after the fact, typically how raw is, and raw is very big. So these are all the data types, and this is put into that LLP. You can see the data type. But here's where it gets really crazy, because every now and again we have customers who have these user defined. So you can have completely user-defined. Not only can I use any of these standards, but I could do my own thing. So this is how you could send depth data or IR data or any other weird data you want to send, or you could use this standard to send non-image data if you wanted to, because you have a user-defined space where you can create your own thing. The key is, though, you need to have the person who knows how to pack it in order to unpack it, right? So looking at it again, that 8 long packets with pixel data becomes a lot bigger because each of those colors becomes a lot built up. And so if we look at it, I think this just breaks it out a little bit more. In the packet header itself, there's information buried in there. You have this idea of virtual channels, so you can send more than one channel along. You have the data type, like I said. You have the word count, which is how much is coming. And then you've got like the calculated there at the end. We've got the packet footer, which again is typically just our checksum. And then you've got the long packet, which contains all of that in the middle there. I'm going to skip over most of this. This is just if you have to deal with any of the synchronization packets and all the packets that are in there, the embedded line data, etc. So what does NI get you? How many are familiar with FlexRIO? Do you guys know what FlexRIO is? I'm going to skip their little video. Raise your hand if you know what FlexRIO is. It's been a while. All right, most of you? Got a couple of you? All right. So for those who don't know, FlexRIO is a type of card, and it's probably 5-10 years ago now. It's been a while since they released these first ones. The idea of FlexRIO was NI wanted to have kind of a standard backbone FPGA card that they could put these front-end cards on. They call them these mezzanine IO modules, or you'll hear them called daughter cards from NI. But it's basically one of their standard FPGA cards that they changed the front end on. And so the FlexRIO camera interface modules is what NI calls their SerDes cards. And it's a FlexRIO with integrated IO, because there's two types. There's the integrated IO, and then there's one that has an external connector out front. And the integrated IO means it's right in there. The first thing you may or may not notice on these cards is they take 2 slots in a PXI system. One of the main reasons is power draw. These cards are pretty power hungry. One of the newer ones is actually a single slot, but it only has 4 channels, not 8. So they've basically implemented the MIPI CSI2 standard on the D5 physical layer. And then on the daughter card, what they've got there are one of these different chipsets. So they have an FPD-Link 3 chipset, GMSL2, FPD-Link 4, and GMSL3. And so these were early access last spring. I think they actually released, this one may have been the last one, in like August or September, released finally. So they have been out. They are usable. What's really kind of confusing and annoying is that there's 3 variants of each module. So there are 3 different 1486s. One of them is an 8 input card. One of them is an 8 output card. And then one of them's a 4 input, 4 output that has serializer and deserializer. So it's a little bit crazy there that that's how they set it up. But it's the same part, like same model number, different part number. So when you go to order it, just be cautious, I guess, that you're getting the one you want, that it's either a serializer card, a deserializer card, or the SerDes card, as they call it. So because of how it's connected there. Each of these cards has to have a high slot cooling capacity, so you can't use this on some of the older PXI chassis. You also likely want to use it on one of the newer PXI chassis that has the higher bandwidth because of the amount of data you're putting in there. One of the things the cards have is power over coax support. This is a bit of a gotcha. So internally, you can power the camera at 12 volts, only 12 volts, and you can have up to 400 milliamps per channel. There is a way to pass through external power, and you can give it 9 to 30 volts DC at up to 800 milliamps per channel without frying the card. So that's all good. There are instances, though, where we've had customers need higher current, lower power. And in that case, you cannot use the power over coax on the card. You need to completely keep your camera power separate from the card. So if that's key is watch the current draw, because this 800 milliamps isn't a lot, and neither is this 400. So a lot of the cameras we've been running, or I've seen them like at 12 volts DC, but they may pull half an amp. So just be cautious of that, it won't fry the card initially, but you want to make sure that you're not going to overdo it. Each of these do have a user programmable FPGA. They have DRAM built in and a whole DRAM manager to handle it. And then they do have the higher Gen 3 interface to the host for PCI. So it does have the higher host bandwidth to get us in there. They all have FACRA connectors on the front, which is kind of standard. One thing that's a little bit interesting to me on these cards, and I'm actually going to click on this and go here, is there is a GitHub repo for the documentation for these cards. So I'm going to drag this over. Interestingly enough, the commits to this repository are direct, like it was 5 days ago, from NI R&D. So the contributors on here are the NI R&D guys working on these cards. So I've actually found better information on these cards here, including like how to use the getting started example and so forth. They have like a tutorial, and it's stuff you won't find on NI's website, but interestingly enough, it's in this GitHub. So if I want to know like about the acquisition, they're like, oh, hey, here's a getting started guide. Some stuff they've started to link back to NI's website, but they have like, hey, here's what you should do. Here's how you do this. And it's a really nice tutorial. And if you want to see like what's coming soon from them, it always appears here before it's on NI's real website. So I will put this link in the chat for anyone who's interested. I'll go back to the main page. It is just kind of buried in NI's public GitHubs, and a lot of people probably aren't aware it's there. So I did want to let you guys know about that. Next up. So one of the things I like to show is like there's all these different parts I've talked about, like the SerDes, the CSI2, and all these different things. Like, how does that play into the NI card? And so you have your PXI backplane, let's say, and that's really connected to the main FPGA of your FlexRIO. On the front end of that FPGA and the FlexRIO is that mezzanine module or your daughter card. And then on the front end of that is the actual physical I/O. And so what happens here is this here on the daughter card is where your SerDes chipset sits. That's where NI actually has the aux power and your power over coax, like relays and all of that. That sits on that daughter card. The FPGA itself has the DRAM, your clock, and the flash memory to store it. And so to kind of align back to our layers of terminology there, we kind of start, we're getting data in, it's FPD-Link or GMSL still at this point, coming in on the connectors, on the actual physical connector. And then at this point, our serializer or deserializer brings it down to the MIPI CSI2 layer. And this is the physical layer that NI uses to transfer between the daughter card to the FPGA carrier. So that's how they're able to have this generic FPGA backend and have these daughter cards. Because at this point, we're now talking the MIPI layer. And then down here, NI has actually purchased and runs a MIPI CSI2 clip. And so how involved you guys are all in FPGA, but I always think of a clip as like a DLL. So they basically purchased from Xilinx the MIPI CSI2 translation. And at that point, they're giving us from the DMA, from the DRAM, the LLP. So I get back an LLP, which is part of that MIPI layer, if you remember we talked about, from this FPD-Link or serializer over here. There's things I can do to control stuff and set information because we've got the I2C, the GPIO. But the key is I don't necessarily have to handle a lot of that because NI's handled a lot of the hardware layers in here. And I just get my LLP back that I then need to turn into an image that the user can use or whatnot. Behind the scenes, these are some of the diagrams for the NI cards. This one right here is for the 1486. And so you'll see this is going into that mezzanine connector. So once you hit this mezzanine connector, that's the FPGA beyond there. So we've already deserialized the data, and you'll see we're deserializing. This is the card that has all inputs, all SIs. And then over here, we've got the all output card. So we've serialized going the other way. And then over here, we've got half serializers, half deserializers. This is the FPD-Link, and you can kind of see the chipset. All the NI documentation calls out the exact chipset and kind of shows you the same thing. The next one is the 1487. And I bring this one up because it's a little bit of a gotcha over here on the left. So if you look here on the SerDes version, we have independent serializers and deserializers per channel. Same thing is true over here on the serialized card, the one that's all outputs. However, NI did something a little bit strange, maybe not, maybe it was a cost savings on the deserializer, the all input card for GMSL. And what they did is they're using a dual channel. So this just makes things a little bit more tricky. and you kind of have to have the same settings. So you don't want to have two different cameras set up here. So this kind of bit us on one of our projects. I wanted to bring this up, that you can have two different cameras between these two, but like if I need different lane rates and stuff, some of that is chipset dependent. And because of how this is a dual channel, it has to have the same lane settings and same data rates for this. I can set different sensor settings, but I can't set different lane rates and different feed rates on these. Does that make sense? So this is a little bit of a gotcha on the GMSL one, is that if you want 4 completely different data rates, 4 completely different cameras, that's fine. You just have to spread them out, or you might need a second card depending on that, right? So that's a little bit of an interesting thing we ran into, that it's in the documentation. It's just not very clear to the users in my mind. And then 14, the other one. So looking next at what happens on the FPGA, like I said, that's where we've now got the CSI2 data going into the FPGA. It's basically getting pushed into the DRAM and then pushed back up to us. And it's kind of showing just your standard. This is kind of the standard diagram, I guess, for all their FlexRIO cards, where they've got data coming in at this point and they're doing something with the data. When it comes to software, you need to have LabVIEW, you need to have LabVIEW FPGA, and you need to have FlexRIO for integration IO. That's the driver layer. And so the driver itself that NI gives you is a clip node. And that gives us the basic CSI2 information. It gives us access to the GPIO, it gives us access to I2C, and it gives us access to all that packet. On the FPGA, NI gives you a getting started example, which kind of gets you partway there, but doesn't do a lot of advanced triggering or anything special. But it's an open FPGA. They give it to you. You can do what you want. And then, of course, you have to write your host code, which is normal LabVIEW. We have been able to, I did want to mention this, we have a customer that only does stuff in C++, C#. And so we were able to take this architecture and expose an API for them. So that their host code is actually C#. And so for a customer, we do have an application where we were able to communicate and build a whole tool chain around it with C#. And I wasn't sure if it would work or not, but we did manage to get it to work. So if anyone's going down that path, we have experience there and could probably help if you needed it. To look at the actual CSI2 layer and like what happens, all of this stuff that I talked about earlier, the lane management and physical layer, is handled in the clip node and I don't need to touch it. The LabVIEW FPGA gives me access to the LLP and some of the pixel and byte packing stuff. And then our host application up top is some sort of UI that the user's either pressing record or doing who knows what, right? Depending on what your application is. The clip hardware allows us to see the CSI2 data and channels, the GPIO, the I2C, and power over coax. So this is all kind of given to you, and this is all custom code that you can put on there. So this is examples, and I gives you, like I said, it's kind of your standard thing for FPGA. It's one of these cards that doesn't have a nice driver, I'll call it, but it's something you can do. Custom hardware we've done. So interestingly enough, Konrad has this whole ABAX platform that sits kind of in front of PXI. And before NI ever made these cards, we had manufactured these for a European automotive company. So about 5 years ago, I was on a project doing a data logger before NI released all their data logger stuff using Konrad hardware. And basically, it was the same idea. We were using a FlexRIO backend module, and we built front-end daughter cards. It looked a little bit different. It was actually 6 channels. You can kind of see this tall thing here. And it sat in an ABAX chassis, which sits around the PXI. And then they eventually made a single slot 3-channel card that was designed for a customer. So Konrad Germany has like the expertise in-house to design and update hardware. So this is where I said, like, NI, if it doesn't fit into one of their 4 chipsets, which they did choose the ones that are the most popular, you may have to wait for them to come up with the next generation. Or Konrad Germany, they were quoting us about 6 months to get one up and running for a chipset that's not currently supported by NI. So it would be the same behavior as the rest of the NI chassis, same architecture. It would just be custom made to use a chipset that you need if it's not available through NI. This other thing's kind of super interesting to me because I didn't realize a use case for it till we ran into the customer who had C#. That was actually, they were using this thing. And so the MIPI pod is one of the reasons that Konrad's part of the MIPI CSI2 standard, like board and whatnot. And so this is a little box, and it basically allows you to go from MIPI CSI2 to FPD-Link. And so some of our customers that do consumer electronics, like automotive for the most part, all has FPD-Link or GMSL. You guys are using SerDes already, and it's already in there. There's a customer who's building like a VR headset, and they're doing development work on it. It's the R&D group, and they need to be able to run the data back to their lab, but they don't have SerDes as part of their device. They don't ever want SerDes as part of their device, but they do have a debug port on their device where they can get to the CSI2 data. And so we're using this MIPI pod to actually tap into their camera and take it back to the lab so they can do all their stuff in parallel, as well as log the data and the behavior of their device. And so it's a little bit of an interesting thing that it's basically a one-channel device, and it can either deserialize or serialize. It's got both to CSI2. So it's a direct thing. It's kind of, think of it as like a one-channel NI card. This is the part that's really super short, and it's just a turnkey little box there. So we've had some customers using that successfully. And then behind the scenes, you'll see it's kind of got this front-end connector that's MIPI CSI2, and we either serialize or deserialize and go to the FACRA connectors. And that's about it for that one. This is kind of a note from the NI script user guide, which is an interesting thing. Sensor integration for cameras is the most difficult thing. And so NI says like FPD-Link serial cameras are relatively straightforward. And then they've got GMSL, are straightforward to configure. One-to-one channel mapping applies. And then they talk about, that 8 input channels are adjacent, share a single dual deserializer. The script required for this configuration will depend on even, odd, or both channels are used. And so that's a little bit of a gotcha. But in general, sensor integration looks like this. So this is an example script from NI for their 1486. And so it's for a pattern generation, because the 1486 and FPD-Link can do pattern generation as a test without even having the sensor connected. And then they actually have another one for this IMX490 Sony camera. And just to give you an example, the one I showed on the right is 54 lines. And literally, it's a Python script, and it says like board, right, I²C. It's not the best documented from NI, I'll say, for an example. It's like, okay, enable pattern gen, select 8 color bars and put things in there. And then if you look at the camera one, well, that's over 2,000 lines that look like this. And it's got information for the 1480-60 serializer registers, the remote serializer, or in our case, the camera down here, serializer register, as well as the imager itself. And so this is the one that's the gotcha. If you don't know or have the information on your deserializer, serializer pair set, or the imager, it can be very difficult to make work. It's basically a reverse engineering thing. You're kind of going down the path of try this, did that work? Nope. And like Luis has gotten some tools that he's created, and I'll show you those in a few minutes, that help. Because if you can get it in tap mode, you can kind of sniff and see what happens, but it still doesn't necessarily get you the full information of all the options. And just to confuse things even more, some of our customers work with the serializer, deserializer companies, and a lot of times they have undocumented registers. So in order to get our agricultural one working, we had to actually get a hold of the support engineer for, at the time, Maxim, now ADI, and he had to tell us, oh, yeah, you need to set register like 34 to AA. And we're like, what on earth? Like, we would never have known that, never have gotten anything to work except for that one guy noting that. And then the guy, the customer being like, oh yeah, I forgot, that was our one special register. And it's like, how on earth are any of us supposed to know that? So that's a bit of a gotcha on the cameras, is it can be tricky. To look at the GMSL scripts, for whatever reason, NI has a C++ script for this, and it looks like this. It's a little bit different, but also similar. And again, you have thousands of lines of code when you have to do the deserializer, the camera serializer, and the imager to get everything in there. Some are labeled better than others. And so Luis has kind of built up some monitoring tools that he's got. So this works with the NI chipsets. You can kind of see down here, he's got a 4-in, 4-out, the driver version he was using it with and whatnot. And he's got it so we have like a 100-page manual. It's insane. I don't know. It's ridiculous. It's just pages and pages of registers and what they mean. And so all we see in LabVIEW typically is the value of the register address. and then what the value is. We don't know what it means. And so what Luis has done is kind of reverse engineered that entire manual so that we can go in there and look for a certain register name, or we can go by value and look in here and see what it means. Like here, oh, if we put, 00, that means that the error output was disabled, or, oh, lock output was disabled. There's all these different things. And instead of going back and forth between this ridiculous user manual and this, Luis has kind of a cool thing in here that checks with the chipsets. And Luis, I think this is only for certain chipsets you've got it working for. I think it's just this 9295 and 9296. He can answer that possibly though.
Yeah, yes, for now, because you need to grab the data sheet.
Yeah, you need to have the data sheet. And again, this sometimes you'll have unmarked registers show up. If the register's not in our data sheet that we have, we don't know what it means either. Or like over here, sometimes it's not decoded. Like we don't know what it means. But at least you can kind of get some information out of there. It's a little bit better. And he's got filtering and different things you can look at. And then this as well is a way to, I think you can like save it to TDMS, right? And then you can look at it later. So this is a bunch of debug information Luis has kind of put together. Like you can scan all the I2C registers on the bus. And I forget, like 90 is the serializer, 91 is the deserializer, or vice versa, something like that. So you can scan who's on there, see who you want to read from.
This is very useful because the chips by default, they have a default address value. So if you power on the NI card and the customer deserializer or serializer, they are probably gonna have the same address because they power on
That's
with
the default one. Yeah.
So you need to change the NI card address to be able to avoid conflicts with the customer, unless they change it, but customers sometimes they choose the default values.
Yeah, it really depends on what the customer has, and that's the biggest help to us on any of these projects is getting hold of somewhere on their firmware team, because if you can talk to the guy who is writing the code to talk to the cameras, it makes life a lot easier. And then he's got kind of a log for the I2C. Luis has been, so you can, I think the point of this was you could kind of see quickly which registers were changing, if any. Looking the wrong way. And then you've got it in Excel, kind of like your export, right? Your CSV. These are the things we need in order to, and this is for your own sake too, in order to be successful in any of these applications, you need to know like the chipset first off to ensure compatibility, because you don't want to spend $17,000 on an NI card when it's not going to work. Beyond that, you should have the following information before you even look at getting the card is, do you know the data rate? Do you know the lanes? Do you know the clock frequency? Do you know the GPIO routing and usage of it? Like, what is the purpose of your GPIOs? Do you know, are you using any virtual channels? Do you have embedded data? What are the power requirements? What's your frame rate, your resolution, your bits per pixel, your image data type? Do you need to do I2C logging or register writing as part of your application? Emulation, do you need to do that at all? And then like GMSL, do you need image data or other data? Like what's buried in there? What are you trying to extract? And so the biggest thing I always tell our sales guys is like, hey, we need direct and regular access to the firmware engineer who knows this, because we can ask him a quick question and he can give us the answer, or we can spend months, trying to reverse engineer it. Like we've got some tools that have made it a little bit easier to do, but it's still not turnkey, because if we can't establish a link between our serializer and, the customer deserializer between the ECU, then we're not going to get anywhere. And in order to establish that link, you have to have like the proper lanes, data rate, clock frequency, GPIO routing. And if any of that's not right, then it's not good. The other thing that's interesting is we need to be able to know on their ECU, is the ECU happy? Because from the camera perspective, it's a little bit easier, because can we see a valid image? Yes. But if we're passing the image on in tap mode, or if we're trying to generate data to send to the ECU, is there a command we can run? Is there something we can get back from the ECU, some sort of query? Is there a CAN status? Like, is there anything we can see to say, is the ECU happy? And a lot of these ECUs are running Linux of some flavor. So sometimes it's opening a command prompt, getting on the device, like SSHing into it and saying, hey, check streams. And it'll be like, yep, okay. or not? Or can we pull a log from their ECU, right? So it's all that information. And so sometimes trying to work with an OEM is difficult because they're getting ECUs and cameras from suppliers and they don't have access to this. If you're at a supplier that has this information, it's probably a lot easier for you to do the application. So I think that was the end there. Do I have, oh, these are all the project challenges, kind of standard. Is there any questions anyone has? I know there was a lot.
I don't hear any snoring.
I know it's sleeping. It's interesting stuff. Like I have not, and so right now, like I'm doing robotics with my kids and talking to them about the camera stuff, it's very applicable because we're doing some sort of object recognition. We're using TensorFlow, which is a Google tool to do that. But that's the application layer. That's way up here. So I'm working with stuff that like a lot of our customers deal with, right? And the way First Robotics works is they give you all of this framework and stuff, and they even give you the whole thing. And it just needs to tell me yes or no, I see an object, right? I follow their tutorial and it works magically. But behind the scenes, there's a lot of stuff going on in all these camera types.
Oh yeah, yeah, there certainly is. When we do some stuff at Aptiv, I've been there almost 5 years now, and they hired me to create a hill for them for their ADAS module. And when we initially were using Xylon data recorders, and their format for saving the data was pretty obscure. And I went through that whole, you're basically your whole presentation here, 24 bits, all of that stuff. Because they were using supposedly it was a robot operating system file format, the BAG format, if I remember correctly. Yeah, and it was specialized, and they had some detail on it, but I mean, it wasn't a lot. And I figured out how to get the image back out.
That's the key, honestly. It's like you don't care about the rest; you just want to see the image.
Yeah, well, it took me a couple of months, but I use LabVIEW, so and I got my bona fides there, and they earned, they were happy they hired me, I guess.
So, they're like, oh, that worked out.
Yeah, and we're still in fact, we just got our not most valuable player. It's called minimum viable product. The hill is now available for use internally by our engineering base to run their, the software engineers basically can load up a ECU with the code that they want to run, and then run different test runs through the modules. And so, yeah.
Are you guys doing all the faulting and stuff too? Because that's kind of the key, is like blank pixels or blank lines or missing things or.
Yeah, we're not testing the hardware so much as we're testing the software.
Yeah, but I mean, even if you blank the software, how does their algorithm respond if it's like a partial bad image, right?
Well, all of the test runs are they're all vetted. They're on a database, and actually they're on a big server we have in Southfield. And like I said, you can globally, with our company, and we're global, can log into the user interface and select an ECU, select a test run, and then run it, and you'll get results back. It's a comparison versus the ideal run. They want to see whether what they did in their code improves that, or makes it worse. And we everything gets transmitted via a 10 gigabit connection, and then decoded. We used a kind of a modified CarMaker. CarMaker's got an open format internet transmission scheme for video.
Yeah.
So we worked with CarMaker, we worked with Xylon, and we imposed a couple of things on them about how we wanted to control it and stuff, and then we've been using it ever since. But yeah, we don't worry too much about losing images. It's more about how they react to the images that have been studied in the past. So we got 5 of those running right now. We're going for 11 hardware in loop. Yeah, this is good stuff. This is
Yeah, the
Wish I
biggest thing
had.
too is synchronization, man. There's like, it's crazy to think about, but like some of these algorithms, if the data's off, it's not a valid response, right? Like if they got
Yeah.
a radar saying one thing and a camera saying another, but it came in at different times, who do you believe?
Yep. You got to have everything time synchronized. That's for sure. And the that's another thing because when you record these things, you break it up into packets, right? I mean, or little sections because how big's going to be any one of your recordings, right? You don't want to go bigger than 4 GB because that used to be a physical restriction on how big your files could be
Yep.
in earlier OSs. And but 4 GB is about 45 seconds worth of data. And
It's amazing to me how quickly we fill up PXI chassis. It's like, oh, okay, never mind. Got to delete that test data.
yeah, so that 45 seconds is going to be overlapped because
Yep.
when you have to start the next recording before you finish first one because you have to save it and then you got to piece it back together again, and that's where your synchronization comes in.
And that's an interesting thing too. Actually, so there's a alliance partner. I don't know, they're out of Korea or something. So we've actually started looking at using, if you've ever looked at the NI rate arrays, they're very expensive. And so we've started, we did some evaluation, by the way, on this product, Radx. So if you ever need a PXI SSD rate array, it's way cheaper than the NI one, and the performance is almost the same. And I slightly edged them out, but it was like, you know what? For the price, this is a much better solution. So if you guys are ever looking, any of you, like seriously, and they come bigger. So like the NI, the biggest in-slot RAID array you can get is a single slot, but it's 15 terabytes. There's a 4 terabyte and there's a 15 terabyte from NI, and this one goes up to 64. And so depending on your data, like we've had really good luck with this one.
Yeah, we've got an ingest system. In fact, I think we were talking to Konrad at one point about putting a front end on that because it's kind of labor intensive, but we have so many different styles of data that come in, physical formats and just getting in it's like a it's like
it's a data mess.
Yeah, it's a Tower of Babel, except instead of language, it's interfacing requirements, and it's unmanageable. But things are changing so quickly. It takes time. It takes time to design something, and by the time you design something, the format's changed, right? And it's crazy.
Or my favorite is like Group A wants this format, Group B wants a different format, Group C wants something altogether different, and I'm like, oh my goodness, can't you guys all pick the same one?
This is how I've made my career though, because I've always understood that you got to just go and build it. And the first one that builds it is going to be the one that they lock on because you got something that works. So, I would work for companies with phalanxes of C programmers and all that. But, with C, it's going to take you forever to write it because you got to have somebody draw up the spec. You got to, with me, I could just throw something together and have it up and running in a couple of, days or weeks. And now we've got a tool, right? And you can use that to test your C code or whatever to get that up and running. But that's going to be 3, 4, 5, 6, 9 months down the stream where we already have something running.
Yeah, and something else we're working on too, as I mentioned, or I showed the NI website where they have the GitHub is like the reuse. There's really not an API for this or anything. So we've been working on with a lot of our projects kind of a hardware abstraction layer for some of these cards because some of the stuff's the same, some of it's different depending on channels and what you're doing. So like behind the scenes, we've got the start of a library. It's not as like happy as where I'd want it to be right now, but like we've got some internal reuse out of it, and we're hoping to continue to grow it over the next couple months. We've got an internal project to try to improve it, right? So, which is good because I love the FPGA cards because there's so much you can do and they're so open, but it's also almost too flexible because then it's harder for everyone to use it.
The FPGAs are something. I like the flexibility, being able to write software that runs on hardware, like hardware.
Yeah.
And that's nice to have a configurable piece of equipment that runs at hardware speeds. because, we know the limitations of software speeds, right?
Yep.
You're kind of bound by the data width and the processor speed and a number of other factors. It's all good. This has been really excellent, Becky.
Okay.
And Luis putting it together. Very, very good. And I see we have a number of people. Usually at this time is when, the food would arrive, or we would have the food during the presentation, and everybody would talk and talk about their, what happened since the last meeting and anything going on, and, what we'd talk about what the next meeting would be about and things of that nature. But yeah, this has been excellent.
For next year. So one of the things, and Dasha was asking us, Dasha, I'm stealing your thunder here. We're trying to get together some more presentations that we'd like to do too. Is there anything that you guys have done in the past? Like I'm a huge fan of, Stephen Loftus Mercer had done a object-oriented programming for LabVIEW developers. And so it was a really good introduction to concepts and theorems and things that my background's electrical engineering. So it was really interesting to me to learn about more CS topics, right? For LabVIEW, because I know LabVIEW. So I wanted to kind of try to revisit some of those. Or has anyone seen the S'mores presentation that Norm Kirchner has given? S'mores, is it scalable, modular, reusable, extensible, simple code?
I don't know anybody out there that has. Feel free to chime in here. Just like I said, this is
or if you're interested, because I think Dasha wanted us to do more user presentations. She's getting on us to come on, guys. I'm like, yep, all right.
Yeah, object orientation is good, but a lot of the times when you're doing that, you have to go and you have to kind of lay out ahead of time what you're going to do, and so much of what I've done has been very ad hoc, and fortunately I've been doing this a while, and I know the right way to do things, but sometimes you have to do it the expedient way.
There's the right way, and there's the I'm going to get it done way. That's what I like about the S'mores conversation. So S'mores talks about making your code scalable, modular, reusable, extensible, but don't forget to keep it simple. Don't go crazy. Take a step back after you go through everything. How much is it really worth the extra effort to do A, B, and C, right?
S'mores, you're saying s'mores, like SMORES?
Yes, S'mores. I do it with my robotics kids. It's
yeah, I have seen that. I have seen that method. It's pretty clever. Having an acronym to remember all the different things.
Yeah.
Yeah, scalable, modular, reusable, extensible, simple. Yep, exactly.
And then there used to be an O, but then it just became S'mores with the little O, because I don't remember what O was, but I whatever it was, I was like, yeah, I'm not a fan of that one or whatever. There was a guy at L3 Communications who started it years ago. Norm Kirchner's kind of carried on the torch. He's done the presentation a couple times at NI Week or NI Connect or whatever it is. And then I do it for my robotics teams, because I'm like, you guys need to learn how to kind of think about things and not just do things.
I think Norm is one of the contributors out there on the community, right? A lot.
Yeah. Norm's yep. I don't know if he works at NI again. Yeah, he's been at NI. He wasn't at NI, but he was a champion for a while. He's really into RF stuff. So if anyone's been involved in RF, you'll see him give RF.
Yeah. That's where I've heard of him, because in my last job at FEV, I was the Roden Schwartz expert.
Yes.
Because I had a lot of
talk about the NI stuff. Yeah. And then Darren Nattinger's always got good presentations too about the hidden gems in LabVIEW and all the different things.
Yeah. So many things, so little time, right? I mean, you want to do everything. So if anyone has
any ideas, I guess just pass topics to
here we go.
Dasha, or put them in there, Hassan. Let us know what you're interested in.
Yeah, if I can just speak up a little bit. So as we're using Python is getting extremely popular, especially in machine learning and applications and all that. And it seems like I'm somewhat getting away from LabVIEW, and it's not easy to create GUI in Python. Unless I'm a total noob, right? So, and I know, so is there maybe we can cover a topic where we can see how we can call Python code in LabVIEW?
Yeah.
Oh my God.
if we can do something like that, you know.
Luis is actually one of the guys who's done more of that at Konrad than anyone else.
Yeah, I actually have a bunch of Python code that I've written wrapped in LabVIEW, and the documentation is minimal in LabVIEW. They have what,
It's gotten
3
better. I wanna
examples?
say, wasn't this year the year they released like a newer version of the LabVIEW Python stuff, so you can actually have like multiple versions brought in? Some of the early issues, I know it was like one version of Python only with this version of LabVIEW, and that was it. But I think this year they had a change where it supports multiple Python versions.
As long
Yeah,
as you
you
have
can
your,
use environments. The Python
Yeah, I think I
environment.
saw the 2 different environments.
as long as you have a path to your code, it'll run whatever. I mean, like I said, the documentation was really sketchy, but I developed an entire app with mouse control, mouse movement, keyboard injection, all of that stuff, image capture, and I had to do all the screen moving around and etc. in Python because it was the easiest language to get all that stuff going on, and then interface it to LabVIEW so I could sequence everything, so I could do what I wanted to do. All the math done in LabVIEW, etc. And
I think the key is the data type, making sure the data types align.
yeah, well, basically it was just having to set up, how are you going to pass the information? Like you said, the data type, how are you going to pass it? It wasn't real easy figuring out how to do it from the few examples, but when you apply brute force, eventually you get there, right?
Yep.
ChatGPT helps.
Keep banging at it until you find something that works and then move forward. Yeah, there's a lot of that Python out there. I mean, I think that would be a good subject. Do you guys have something that you present on that?
I think we had something, Dasha. What did we have? That was
On
on our
the
list, at least I remember.
Yeah, hold on.
And just so you guys know, at times the examples, so for example, you go to any of the NI events and they show you how SerDes works, right? The example they show is the simplest one, right? One channel. Yeah, look, we got
Yeah.
analog input and we're displaying it, right? But when you actually go in to code your own application, it's a lot more complex, right? So that's how I feel about the Python integration. That the examples they show, it's easy. They're easy examples, right? But what about some of the complex stuff, right? So
Yeah, that's what's bad about PowerPoint. You understand it while you're looking at it, right? Or at least you think you do, but trying to retain it and actually comprehending what it is that they did and how that works for you. That's yeah. There's some area that need to be developed with a lot more background information. So there's plenty of room for elaboration on these things. I think there's a big demand for that. Python is becoming more and more popular.
yeah,
It is. I wonder what the next one's going to be, though. There's always one. I feel like forever it was Java. Like Java was the cool one.
Yeah, I
Now
don't
it's
know.
Python.
Unfortunately, I'm thinking it's going to be like probably named Club, and it's going to be basically just a big, hammer, and nothing works. Boom, boom. Right.
Sounds about right to me.
But I mean, that's pretty much just my comment on society nowadays, I think. Sorry.
LabVIEW executes faster than Python, though, right?
Depending on what you're doing, it can.
Yeah, I guess it depends because some of that, some of the LabVIEW code is.
There's inherent parallelism in LabVIEW that makes it
exactly,
win.
exactly, and that's one of the things I rely on in my code is that parallelism, that you don't have to code in other languages. But yeah, you can get really good speeds out of it. Like I said, I made an app because we had a program that was an interface to a hardware device, and there was no API for the program, so we couldn't remotely control the program or anything like that. So I just made a tool that looked at the screen and found the buttons and then, poked on the buttons to make it work and typed in, but all that poking and the typing and all that was all done in Python. And I had to interface all of that. And there were other issues because, while you're doing that, you're using the keyboard and the mouse because you're actually moving the mouse, right, to do the clicking because there's no way around that. So there's a lot of issues for that. But yeah, so a lot of the Python stuff, there's add-ons that do a lot of that stuff for you. Yeah, something. Will this recording be shared? Well, I'm going to post it on the community site for NoClug, and so people can view it. And actually, we could stop recording at this point unless people want to have our conversation here as part of it.
Bill, I'm also planning to like edit it, just make sure that we don't show the attendees, kind of crop out just to see the presentation. And then we're going to add it to our Konrad channel where we have some other presentations from the past too.
If you've I'll tell you what, because I usually have to do that myself. So if you're going to do that, and if you could share a copy of it back with me, I could put that on the NoClug site instead of the raw recording.
Yeah, of course. Yeah, just I don't know if I'm going to automatically get access to the recording. I think as a participant I do. I'll let you know if I have trouble accessing it, but I just need a raw file to put it in my program.
Yeah, shortly after we stop recording, this will be available, and that's why I had to go through this convoluted thing of creating an entirely different email address in order to have access to a place to put this so everybody could have access to it. So instead of using my normal bill@ossipoff.net, I've got this convoluted thing at Microsoft.com. So
yeah, I can certainly take care of it in the next couple of days and post it on our channel and send you a link and send you the file to share as well.
Yeah, cool. That'd be great. That'd be great. And we can discuss this over email or text or phone calls. Usually the way timetable goes, I like to have a meeting in February. That way there's one in May and then in August and normally in November. November next year might be a little bit brutal though, given that there's a presidential election. So that's a target, not a frozen date. But and I likes to have the user group people like to have a schedule ahead of time. Maybe we'll put one together for 2024. Maybe it'll be August and October or something instead of November.
Yeah, probably do in October. If I were you.
But yeah, people that want to contact me, my typical address, as I said, I could put it in the chat here. Is bill@ossipoff.net.
And Bill, correct me if I'm wrong, but as I understood from our discussions, your guys are kind of too far from the Farmington Hills to try to do in-person meeting next year, correct?
Yeah. Well, for instance, for instance, some of the people here are from Ford and Dearborn. So I don't know how far that is from Farmington Hills, but somewhere in where's the Continental at, Luis? Are you working from home?
Conti's in very close to FEB, so it's in Auburn Hills.
Yeah, so you're in Auburn Hills. Yeah.
Yep.
So yes, a lot of that, this time of year especially makes it difficult for people to show up over there. But I mean,
besides construction traffic.
Yeah, I can contact
construction right now.
Yeah, everything's well. I think they shut down the construction for the holiday season, but it'll be back up in January.
Yeah.
As soon as the snow starts flying real big time. But
still down lanes on 96.
Yeah, has anybody heard whether the user group coordinators are now offering a budget again for lunches? Because I mean that would be big if, as I know, there's a lot of people that like to attend these mostly for the lunch, but they get educated at the same time. And
Yeah, we can definitely sponsor pizza lunch. I don't think that's going to be a problem on our end. I'm more concerned on making sure like that people don't have to drive 45 minutes. Oh, it's a cat
Yes.
paw.
yeah, yeah, that's one of my two boys. Cato, he's telling me, Bill, it's been a couple hours since I
He
ate.
wants
So
lunch.
what are you doing? What are you doing? Why
That's
am
the
I
best
not?
part about working from home is my dogs. Although he was barking earlier, hopefully nobody heard him.
Nope, no,
Yeah.
we didn't hear it. Becky.
Yeah, I didn't hear anything.
Teams does a good job clearing it out. I'm like, you go away. You're annoying me right now.
So
Yeah,
the-
so but yeah, hosting an in-person event is definitely on the table. Would love to do it. It's just a matter of making sure that you guys don't have to sacrifice an hour of your time just to drive to us. And as far as the support from an eye goes, with the acquisition of Emerson, nobody knows what's going on right now over there. You know, people, the organization is getting reshuffled. I'm not expecting to get any input into what's the next step is going to be till after New Year and probably even later than that.
The only thing I'll say that I am kind of happy about with the Emerson acquisition is they are putting the focus back on LabVIEW. From what I know from my meetings that I've had internally and stuff, that like they're, if you remember for a while there, and I kind of divided themselves up into like the semiconductor business group and the automotive group and whatever else, I don't know, the business groups. And like LabVIEW kind of fell by the wayside. Well, it's got its own group again. Like it's its own thing. It's coming front and center. That's one thing Emerson really wants is like and I don't know if you noticed any of the public releases, LabVIEW was always mentioned. That was something they've been very clear about, that's one of the reasons they wanted NI was because of LabVIEw.
yeah, I
not
think
necessarily all
LabVIEW
the
is their
other stuff.
gem. I think LabVIEW is the
So-
real gem of National Instruments.
Yeah,
Makes
and I
the
don't know if they
programming
lost sight of
easier.
that themselves or what, but like there's some strange things that like people were let go that I wasn't liking that they let go, like Nancy Hollenbach. Nancy, well, Jones, she got married now. Nancy was let go recently, and then Lyle was like a partner manager. So I haven't been very happy about some of those. But like, I'm like, well, I don't know. I'm just hopeful that they're gonna do something more with LabVIEW.
Yeah, I second that, Becky. I heard the very similar notes that there's going to be renewed focus on LabVIEW. And I kind of dropped the community, as we all know, you know, back in 2019-ish. So hopefully we'll get a little bit more support and, you know, it will come back as a regular cadence.
Yeah, I do have some connections with the user group support people. At least I did.
Whoever, if they're still there,
in the
hopefully.
middle of last year, so and it was still active after the acquisition. But you know, again, you buy something, right? You look at it, you go, "What did I buy?" And then you got to figure out what you need and what you don't need, and make some adjustments. And you got to take control of it. And it's just what's the word? It's like crossing through the sound barrier, right? You got a destabilized region until you get past it, and that's where we're at right now. We're kind of in the rough, and we're going to push through and get to the other side, move forward. So I'm pretty sure that's the way Emerson looks at it, because they're not going to take something like LabVIEW with so many users around the world and they're not Apple, in other words. You know what I mean?
Well, and the other interesting thing is, so like I'm on the board of directors at a local YMCA, and so are a bunch of people from Emerson, actually. So that YMCA was founded by a company that was purchased by Emerson, like long story short. And I've talked to a couple of them, and they're like, as far as they know, they're like, Emerson didn't buy NI to get any of the partner business. Like they don't necessarily want to do applications. They bought NI for LabVIEW and the hardware. Like that's why they bought NI. That's what Emerson does, is they make hardware. They don't do solutions. Because I was like, do you think the partner program is going to go away or anything? And he's like, I don't think so. I imagine that would all be the same. So that's an Emerson person talking, but who knows, right?
Yeah, well, I could see it that way. I mean, that's how NI made its money, right? The software was there to get people in the door to make the hardware easier to use.
And
that's how I started.
Emerson does, they sell stuff. They sell stuff. They don't sell services. They sell stuff.
when I first started using NI products, it was 1994, and I was using it to control a GPIB interface and a few other things, but LabVIEW really didn't even. I had no idea LabVIEW. I was writing code in Microsoft Basic that I connected to the equipment through that interface that NI provided, and I can't for the life of me, I can't even remember the name of it anymore. They had
The instrument driver thing.
Yeah, the instrument driver layer, but there was a name for it, and can't remember the name of it. But what the heck? Don't use it anymore. So got other things to keep in my head now, right? What day is it? But yeah, I'm sure that's why they need it, because anything that makes equipment easier to use will be a draw to that equipment manufacturer for customers. And I've seen some really ugly software for equipment.
Oh yeah.
My 2 bits. But
Hey,
yeah,
guys,
anybody, sorry, go ahead.
yeah, I have a question. This is more related towards the certification part of FNI. I'm struggling deciding to, keep being active, but to remain, being a CLA and CTA. And I dropped the support to the CLA summits. That was my, my motivation to keep being certified. But now, I don't know, with the acquisition from Emerson, I don't know if it's worth to keep being certified, because now with the GLA, everybody can get into and everybody can interact with each other. So I don't find any more valuable to just being certified. So I want to get your thoughts on that. What do you guys think?
Didn't that type of thing happen before Emerson? Back around like 2019 or something?
Yeah, that's what we're talking about. That's when they dropped all their community stuff. Like that's when NI really dropped the ball and changed things. So I mean, for years now, there hasn't been a real benefit to having a CLA or CTA. Like there's no special things you get, except for like if you're interviewing for a new job or something, let's say, right? Then it's like, well, okay, I was certified.
Yeah.
But yeah, you're
Or
right. I
for
mean, there really
advertising
isn't.
your company.
Well, advertising your own skills, really. That's
I
it
haven't
used to
checked.
be beneficial because there were things that NI gave to you as a CLA, CTA, right?
Right.
Right. I think last year, one of the members, and I don't see anybody here related to him, Pete Broder, needed to get recertified as a CLD, and he was gathering his records, and he never got back to me to tell me he didn't. So I don't know. And this was late spring, maybe early summertime, right around the time that Emerson acquired NI. So I don't know if it may still be active. I mean, and I see the benefit of having that as a piece of paper, if you will. I mean, I used to operate nuclear reactors, okay, but it wasn't until I got my 4-year electrical engineering degree that I could actually get the kind of money that my talent is worth. And because nobody knows, I mean, because Hyman Rickover, the admiral that created the Navy's nuclear power program, deliberately kept us from being the training being relatable to college courses. That's because otherwise you'd spend your couple of years in the Navy as a nuclear operator and you'd go into some really nice job and they wouldn't be able to keep anybody. So I could see the benefit of having the piece of paper. Simply, as you said, if you're looking at changing jobs or anything like that, people can look at a piece of paper and relate to that. Another 2 cents, but somebody else had another question or comment?
The certification reward, or it's the certification by points thing should make it fairly easy to maintain your certification without having to deal with
I
anything.
believe that's what I was talking about. I believe that's still operating. There's a place you send your transcript. Basically, you take the day of the meeting, the subject of the meeting, an email from the organizer, and you put that in a spreadsheet, and roughly you get 5 points for attending, 5 points for organizing, in addition to 5 points for attending. What there used to be 15 points for doing a beta software. There used to be points for different seminars and presentations and the NI week.
Yeah, they still do that, I think. I think that's still around.
Yeah. So, I mean, the tests are pretty difficult. And, if you try to certify by test, the last time I took the CLD exam, I was one question away from not getting certified. And that was a shock to me. But there's too much reliance on wiggle words on these exams.
Still probably better than the mess that the full CLD or CLA exams are, with the external
written
company
questions,
monitoring them.
Yeah, the written questions to me, multiple choice. But when you had the right code, that was always the way that I
Oh, I
preferred.
mean, the test
that.
is probably preferable, but the proctoring of it now.
Yeah. But yeah,
Because they use a third-party company to do that.
Yeah,
Unless
remember.
that's changed, Becky.
No, they're still doing that third party, I think.
Yeah.
They changed third parties. That was part of the issue this year, was like they didn't have a testing place because they were changing who was doing it.
Always gotta try and negotiate a better deal, right? That's
Yeah.
That's
probably what they were doing. They had to save all their money just so they could look better for getting bought by Emerson.
I was going to say, for people that don't know what the cameras look like that people use in their vehicles, this is one.
Oh yeah, there's one there.
Yep. You have a little bit.
I have an ECU and a camera in my back room because for a trade show we had a demo and I brought it home, and it's like, but it needs to be networked, and so like we have a network rack back there, so it's kind of weird.
I have a complete prototype of my hill here, because sometimes you have to make changes, right?
Yep.
Things, and we would, as soon as it's no longer needed, they'd scrap it, use the material for something else, and you don't have any way to go back to it. The space program, at least, when they build something that sends people up into space, they build extra and they have it on the ground. And if something happens, you can go into that thing and go, well, what happened? What you mean? You press this button and you push that lever and then this happened? And you try to duplicate it on the ground, right? And then they can come up with a way to fix it. But for too long, we've been not spending the money on keeping that stuff around, and we've been getting rid of it because it takes up space. Looks like everybody's going. I appreciate all of you for what you've done to help make this successful. Been fun. We can. I'll send out a note. When I send out a note, I'll send it out to everybody, and we can have a little short meeting somewhere and talk about the next subject. But I think that Python idea is a good one.
Yeah, we could do that for sure.
Could do something like that, and then let's talk about the time frame, like early February, maybe first Wednesday or second Wednesday of February. That sound about good?
That should work.
All right, then we'll work on that.
We'll get something going. If NI is not going to do it, we'll do it. That's what I vote for.
Well, that's how it works. I mean, look at it like NI being the government and you guys being, a major corporation that's carrying on, right? The government wouldn't be anything without the major corporations doing the work.
Someone's got to do it. So.
Exactly. God bless you for it. God bless you for it. Thankless work, but we got to do it.
Someone's got to do it.
Yep.
Awesome. All right. Well, thanks, Bill, for getting it all together.
Yeah, enjoy that.
Nothing like it.
Yep. Thanks,
You're
Bill. I'll keep you posted on the recording editing. Like I said, if not, I'm actually taking Friday off, so I don't know if I can knock it out in a day, but definitely early next week I'll share it.
That's fine. I'm off from the 22nd to the rest of the year.
So
That's
are
about us
we.
too, so,
Yeah.
yeah.
Hallelujah.
Same holiday.
Yeah, I know. We're almost there. Almost there.
All right. Well, have a
All
Merry
right.
Christmas. Talk to you
Thanks,
guys next
Have a
year.
good Christmas.
Thanks,
Happy New
Becky.
Year.
Thanks,
Good night.
Louis.
Bye, guys.